Good day. We've done a lot of calculations of determining the pH for weak acids. And a lot of times we've been able to make assumptions that we didn't have to worry about a starting concentration of H plus as we did our ice chart getting to equilibrium. But here it spells out what we do if Ka is larger than 1.0. Now that's hard for me to see, so I'll make it jumbo. Well, 1 times 10 to the minus 4. And our weak acid concentration is less than 0.1 moles per liter. So what we're going to run into is we're not going to be able to make those safe assumptions. It says under these conditions, the change in concentration of acid is significant and must be included in our calculations. And the result is we're going to get differences here. So here it said we get 0.063, but if we actually correct it, we get 0.0059 for both these things and 0.049 below. And this is showing you how to do the uncorrected approximation and why it's better to do the corrected one, which involves the quadratic equation or setting your equation to finding the zeros from the equation. So this is not a formal assignment. You can just read through it, and then you can ask questions about the difference between uncorrected and the corrected quadratic calculations. And it says, hey, here are some samples you can do for practice. Is it possible I'll put this on the test? Well, it's possible to be on the test. It definitely will not be on the final exam, so this is just a taste of it, just for future reference. So using a quadratic with Ka, obviously not an assignment. I'm simply having this in your notes as a tool to see when does it matter when we have this H plus from the dissociation of water itself.